Hi, Assalamualaikum. In this video, we are going to discuss about quantum numbers. In this video, we are going to explain all four quantum numbers of an electron in an orbital. First, let's define the orbital. Orbital is the region in space around the nucleus where there is a high probability of finding an electron. Which means, in other words, it is about an address of an electron in the orbital. So how we specify the position, the exact position and the energy of an electron in the orbital. To specify the exact position of an electron in an orbital, we can use quantum numbers. This quantum number describes the energy level of an atom, the shape of orbital, the number of orientation of orbital, and the spinning motion of electrons. The four quantum numbers are called principal quantum number n, angular momentum quantum number L, magnetic quantum number m, and the spin quantum number S. First, let's discuss the principal quantum number n. The principal quantum number n indicates the energy level and the shells. As we can see in the Bohr atomic model, which is the nucleus at the center of an atom was surrounded by the electron clouds. The electrons was distributed around the nucleus in a specific energy level. So as you can see, the energy level can be indicated as n equal to 1, n equal to 2, n equal to 3, n equal to 4 to infinity. Therefore, the value of n can be 1, 2, 3 to infinity. The principal quantum number n is also indicate the size of orbital. For example, for 1s orbital is smaller than 2s orbital. As the energy increase, the size of the orbital become larger. The next quantum number is called angular momentum quantum number L. This quantum number indicates the shape of orbital. As we can see, when the value of L is equals to 0, this represents the s orbital. This orbital have a spherical shape. When L equal to 1, represent the p orbital with a dumbbell shape. When L equal to 2, represent the d orbital with a cloverleaf shape. And L equal to 3 represent the f orbital with a double cloverleaf shape. The value of L depends on the value of n. So, L can be from 0, 1, 2 until n minus 1. For example, let's say we have a value of n equals to 1. The possible value of L can be 0. So this value we get from n minus 1, which is equals to 0. So this number represents the maximum possible value of L. So next example, let's say when n equals to 2. So the possible value of L can be 0 and 1. So we get this number from n minus 1, which is equals to 1. So this number represents the maximum value of L, which is we can write from 0 to 1. So another example when n equal to 3. So the possible value of L, it can be 0, 1, and 2. So this number we get from n minus 1, which equals to 2. So 2 represent the maximum value of L, which is we can write the possible number from 0, 1, and 2. And next, let's say we have n equals to 4 So the possible value of L can be 0, 1, 2, and 3. So this number we get from n minus 1, which is equal to 3. So this number represents the maximum value of L. So we can write all the possible value of L is from 0, 1, 2, and 3. How to name the orbital? When n value equals to 1, the L can be 0. This represents the s orbital, so it is called 1s orbital. When the n value equals to 2, the possible L can be 0 and 1. So when L equals to 0, it represents the s orbital, so this orbital is called 2s orbital. When the L value is equal to 1, this represents the p orbital, so the orbital is called 2p orbital. When the n value is equal to 3, the possible L can be 0, 1, and 2. L equal to 0 represents the s orbital, so it is called 3s orbital. When L equal to 1 represents the p orbital, so it is called the 3p orbital. And L equal to 2 represents the d orbital, thus it is called the 3d orbital. The energy of orbital is increases from 1s, 2s, 2p, 3s, 3p, and so on. The size of orbital is also increases according to the increasing of energy. For example, the size of 1s orbital is smaller compared than 2s and the 3s orbital. The next quantum number is called the magnetic quantum number, m. This quantum number indicates the number of orientation of orbital. The values of m depends on the value of L. M can be from negative L, 0 to positive L. If the value of L equals to 0, this represents the s orbital. The possible value of m is also 0. So this number we get from the range of negative L to positive L. From the value of m, it indicates the number of orientation of the orbital. So since L equal to 0, the value of m is also 0. So we have only one value of m. One value of m represents one orientation. So since this orbital is represented for the s orbital, so there is only one orientation of the s orbital. When the L value is equals to 1, this represents the p orbital. The m value can be from negative 1, 0 to positive 1. So this number we get from the range of negative L to positive L. Since the m value represented by 3 numbers, so it shows there are 3 orientation of the p orbitals. The 3 orientation is called the pz orbital, px orbital, and the py orbital. When the value of L equals to 2, this represents the d orbital. The possible value of m can be from negative 2, negative 1, 0, positive 1, and positive 2. This value we get from the range of negative L to positive L. From the value of m, it indicates we have 5 numbers or the value of m. This indicates 5 orientation of the d orbitals. The 5 orientation is called the dxy orbital, dxz orbital, dyz orbital, dx square minus y square orbital, and the dz square orbital. The next quantum number is called the spin quantum number. This quantum number indicates the spinning motion of electrons. The value of s can be positive half and the negative half. This value indicates the clockwise rotation of the electron in the orbital and the anti-clockwise rotation of the electrons. This shows that each orbital can hold up to 2 electrons. Here are the maximum number of electrons that can occupy in each of the atomic orbital. The s orbital has only one orbital. So since in each orbital can occupy 2 electrons, thus the s orbital can have only 2 electrons. For the p orbital, it has 3 orbitals, which is represented by the px, py, and the pz orbital. Thus, the p orbital can hold up to the maximum of 6 electrons. For the d orbital, it has 5 orbitals, which are represented by the dxy orbital, dyz orbital, dxz orbital, dx square minus y square orbital, and the dz square orbital. We have 5 orbitals, thus it can hold up to maximum of 10 electrons. For the f orbital, it has a presence of 7 orbitals, so the maximum number of the electrons is 14 electrons. So we can summarize that the quantum number determines precisely the position of an electron in an atom. This is represented by the 4 quantum numbers N, L, M, S. In the next video, we are going to discuss for some questions about the quantum numbers. So I hope to see you then. Bye!